Hello, and welcome to the Superb AI Academy. My name is Sam, and today I'll be talking about our Model Diagnosis tool. Model Diagnosis is a feature in the Superb Curate module that will let you examine the performance of models trained in the Superb Model module, as well as your own models trained elsewhere. We can access Model Diagnosis directly via Models page, as you can see here, from within the Model module. This will take us to Curate. We can also view all model diagnoses for a specific Curate dataset in the Model Diagnosis tab. When we open the Model Diagnosis page, we'll first see an overview of the model's performance, starting with a confusion matrix comparing ground truth to model inference results. We'll come back to this in a minute. Further down, we can see a breakdown of model performance by class, then a PR curve showing a trade-off between precision and recall, which we can view for the model as a whole, as well as by specific classes. Next, a graph of precision, recall, and F1 score plotted against the model confidence threshold, on which we display our calculated optimum confidence threshold. And finally, we have a breakdown of the I/O distribution of our inferences versus our ground truth, and the confidence distribution of inferences. Let's move back to the confusion matrix. Currently, we're seeing a statistical breakdown of the model's performance, with correct inferences, that is, true positives, along the diagonal, false positives on the bottom row here, where objects are being detected where there are none in our ground truth, false negatives on the rightmost column, where objects that do exist in our ground truth are not being detected in our model. Let's click on the false negative for bikes. This is going to take us to the image view, where we can look at all the objects that were labeled as bikes in our ground truth, but not detected as bikes by our model. By default, this view shows the specific objects in question. We can click Details on a specific image to view the full image, and we can also use this View Full Image checkbox at the top to display all the images in their entirety. Reviewing these images quickly, we can see a few common issues. It looks like our model is struggling to pick bikes out of a bike rack, as well as very small, distant, low-resolution bikes. This information could help us improve our model on subsequent iterations. Moving back to the confusion matrix, we can also see some scattered objects off the diagonal. These are misclassifications, objects that are one class in our ground truth and another in our inference results. Let's click on one of these. Here, we're viewing images that are labeled people but are being identified as riders by our model. We can see immediately that we have an interesting edge case here, where a person is standing behind a bike but not riding it. In the next image, a person is standing in front of a bike. Knowing exactly which edge cases our model is struggling on can help guide our future data gathering or labeling tasks. The confusion matrix isn't the only way to filter the image view. As we can see on the right here, using the confusion matrix has configured a set of filters for us automatically. We're looking for misclassifications, where the prediction is a rider and the ground truth is a person. Let's reset the filters. Now we're seeing all objects in the dataset, in both the ground truth and the inferences. Let's filter for false positives for the person class. At the bottom here, we can further fine-tune, looking for specific ranges of intersection of reunion between our ground truth and inference, or inferences that fall within a specific confidence range. We can pick out just high confidence inferences, for example. We can see 2 riders and 6 people, which clearly should have been labeled in our ground truth. We can take this information back to Superb Label so we can review and correct these images. This can be easily done with the Add to Slice option in this view. If I select all of these images, I can select the Slice option and either create a new slice or add to an existing slice. We can use these options at any point from this view, letting us preserve specific subsets of our data for further review and correction or use in model training and testing. That's it for model diagnosis for today. Thanks for watching, and I'll see you next time.